Okay. Okay. First of all, thank you very much for the opportunity to visit University of Chile as a Fulbright scholar. And thank you for all the arrangements and the hospitality. I really enjoyed my stay. Um, Met a lot of your students and found them to be really wonderful and very qualified. I hope that we can continue with some collaboration in the future. As I said, I've started to work on 2 journal papers that hopefully I can work with you, just part of it. And uh, given that now it's very easy to get in touch with Zoom, for example, we could do a lot of the collaboration remotely. I think we could easily interact. So communicating has become very easy because of Zoom and similar programs and similar software. So it doesn't have to be. It doesn't have to be that we are in the same place. So I hope we can continue in the future with many endeavors, collaborate. I do hope that some of your students will apply to us and pursue advanced studies, master's or PhD. I have had a student from University of Concepcion, and I found him to be very, very bright and an excellent student. So I hope your students will be even better. So they will be welcome to come to my place. If they're interested, they can just contact me. So, yeah, so I hope this collaboration of us will continue way into the future, even after I have left. So I'll now share my screen and so you can, you need to make me a co-host.
Of course.
I can share.
Okay, Professor.
Okay. So yeah, one of the potential collaborations that we can have is through my center, particularly in hiring of graduate students. I am now the director of the University Transportation Center for Underground Transportation Infrastructure. It's a shortcut of UTC-UTI. I know the transportation is repeated twice, but that is required by our sponsor. So, okay, so what is the University Transportation Center? It's a collaborative effort between 3 universities in the US, Colorado School of Mines, which is my institution, California State, Los Angeles, and Lehigh University. So Lehigh is our West Coast partner, and Cal State LA is our West Coast partner, and Lehigh is our East Coast partner. California State LA is also our minority Hispanic serving institution. This center was funded by the U.S. Department of Transportation. There was a competition in 2016. What happened? There were more than 300 applicants. So I'm sorry, I unblocked so many, accidentally unblocked so many slides, hidden so many slides, so I have to unhide them again. There goes. Sorry about that. So again, this was as a result of the competition in 2016. So we are now in our 6th year of operation, and we are supposed to finish next year, but we have applied for a new renewal. This was funded under the so-called FAST Act, the Fixing America's Surface Transportation Act. It's an act by the U.S. Congress. Its aim is to improve the durability and extend the life of transportation infrastructures. We receive a budget of 7.5 million. Actually, it's been extended to 8 million from 2017 to 2022, and it's been extended to next year to 2023. We're required to provide cost match. And this is very common in the US these days. it's not only difficult to get the project, but you have to match the funding. But most of our funding are in kind. If, for example, use of data, hosting of students, etc. So yeah, so it's
that is that you have to put also money from the university. I mean, the equivalent to the 50%.
No, we have it's from other sponsors. It's from other sponsors,
okay.
industry. But also the university is able to share some of the budget by, for example, charging charging some of my time to research. So summertime we work. We're supposed to teach, but we also have to do research. So that amount of time that we will do work for research is also considered a contribution.
Yeah.
So it's some kind of accounting. But most of the cost much comes from the industry. Through in-kind support. Industry provided with software, data, hosting of students, and advice from their personnel. So this is very common in the US now. It makes it very, very challenging because not only you have to get the grant from the government, you also have to provide additional funds. The Department of Energy only requires 20%. The only agency that doesn't require cost much is the National Science Foundation. But the National Science Foundation is very tough. It's in my area, you only have about less than 5% chance of being funded. So it's a very
difficult to get anything from there. Yeah, it's interesting.
Yeah, I have personally given up on the National Science Foundation. I haven't submitted the proposal for more than 15 years now because it's very difficult, but also they prioritize young researchers, new researchers, instead of more established ones like me. Okay, so as I said, there were 212 applicants for this, and only 32 were funded. Okay, so these are the locations of the funded centers. The green dots are the lead. So we are the lead in this center, and the only lead university in Colorado. Many other Colorado universities tried to get the center, but we were the only one who managed to get it. It's actually the first Department of Transportation center at my university. And of the 32 that were funded, it is the only one focused on underground construction. So yeah, the reason for the significant funding from the Department of Transportation through the FAST Act, the Fixing American Surface Transportation Act, is that American infrastructure has been so degraded, truly in a bad shape. Every so often, the American Society of Civil Engineers publish a report card which grades the different components of the US infrastructures. You can see here the roads, which is one of the main missions of the center, has a grade of D. Railway C+, bridges C+. So we are really in a bad shape. A lot of the structures in the US are in big trouble. A lot of them are collapsing. So causing a lot of problems, not only in transportation delay, but also in damages. Okay, so let me review the Surface Act, the Fast Fixing American Surface Transportation Act. It was signed into law by President Obama in 2015. It's the first long-term funding for improving the transportation infrastructure in the US for many decades. Its total budget is $305 billion from 2016 to 22, but as I said, it's been extended. So most of it is for streamlining project delivery and partnerships between the federal government and the local governments to move forward with long-term partnerships for critical transportation infrastructures. Why did we create this center? Well,
So one question
Underground
about
transportation.
this project. Can one short question? So in the project that you applied for, it was the goal of the project was defined by the agency, or you presented a proposal like with the, I mean, this is my idea of, I mean, what needs to be done here, or
Yeah, it's the only thing that they prescribe is that it should be about surface transportation. So roads, railways, waterways, are covered. What is not covered is, for example, air transportation is not included in this one. So anything else is fine. It should be about transportation and to improve many aspects of the transportation. So it's pretty free, very free. Later I will tell you the specific areas, but in general, it's a very open competition as long as it's on transportation, and we are free to select the topic that we want to do. Now, Colorado School of Mines is, of course, known for underground transportation, underground construction, tunneling. So we use that to sell, to market our idea. And fortunately, the Department of Transportation liked it, and so funded it. So it's been a big accomplishment, I think, for Colorado School of Mines to get one of the centers. So yeah, it's pretty open as long as it's on transportation infrastructure, but surface transportation infrastructure. But there's some specific areas they wanted us to agree to put on, and I'll go into that in a bit later. So the reason why did we propose this is that underground transportation, particularly tunnel, is becoming the only way to meet the demand for growth in urban areas,
yes.
increased density, traffic congestion. It's the only way. We're running out of space. So underground transportation is an essential component of moving people and goods. I see also in Chile that you have been very active in having transportation infrastructure. You have a well-functioning subway, metro, railway system for moving people. I think that's a huge component of your infrastructure. Also road tunnels. I see many road tunnels for connecting different parts of the city. And I believe that there will be more in the future. There will be more demand for tunnels. And as I said, there's getting fewer options available. Underground transportation provides many aspects for long-term sustainability. It's one of the most sustainable solutions for moving people and goods. But the future tunnels will be deeper, larger, more complex, and will have multiple uses. At the same time, many of our existing tunnels in the US are beyond nominal life and need repair and upgrades. Tunnels, of course, are expensive and complex, and many tunnels have unfortunately encountered major problems before. And if we want to maintain and retrofit and extend our underground transportation infrastructure, they will certainly more expensive than other forms of transportation infrastructures. So tunnels are really expensive and complex and prone to failure. So not only in the construction, but in the maintenance. There are many advantages to underground transportation, particularly long-term sustainability, and particularly in urban areas. Tunnels reduce congestion and travel times, reduce fossil fuel use and emissions. And in fact, we're developing ways to capture the emission inside the tunnel, so we can capture the carbon and sequester the carbon. It has a very positive use of the land. As you can see here, how beautiful this is, very green. Above the tunnel, you have a park, okay? You can reduce urban sprawl and traffic noise and prescribe landscape and diversity. So for example, this could be a corridor to allow animals to move wild animals to move from one area to another, and they're very resilient. In fact, tunnels have been and will continue to be used as safe areas in case of natural and anthropogenic damage or incidences. In the US, we have currently many projects for underground transportation area. San Francisco, we have the Muni Central Subway, Silicon Valley Transportation Bay Tunnel. In Seattle, in New York City, in Washington, D.C., we have many undergoing projects. We are not, the US is not as big, a big user of tunnels like in other countries like Europe, China, Japan, but we're getting there. Okay, so these are some of the longest tunnels in the world for trains and cars. Longest is, of course, the 60-kilometer Gotthard Bay Tunnel completed in 2016. Second is the one in Japan. Now, this tunnel was constructed over many decades, and it ended up some of the workers in the tunnel, their son took over the projects, the work from their parents. So this has become also multi-generational project. So many more. Records are being beaten every time. This is the Gotthard Bay Tunnel, the longest in the world. Took 70 years to complete, almost 60 kilometers. The cost is 12. How much is this? 12,500 million. How much is this? That 12.5 billion project, employed 2,600 people. Okay, so the TBM machine
given the length, is only for trains, or no? It's not the.
It is for yes, it is mainly for trail. Yeah, you're right. It's for rail tunnel. It connects Switzerland to Italy over here. It connects Switzerland to Italy. So it's mainly for trains. And I will show a project that talks about road tunnels, but yeah, this is so far the record. This is a project that I have worked with in Norway. It's the world's longest road tunnel. And being a road tunnel, it has a different demand and requirements than a rail tunnel. Gathering of exhaust, for example, is much more important. Let me see, my internet is not more important. So it poses a severe problem. Now, this tunnel is 24.5 kilometers. This is a road tunnel for cars and trucks and other road vehicles. It connects the two towns, total of 24.5 kilometers. Previously, the only way to go from one town to another is to go above here through a pass, which is always covered by snow. I tried crossing this when I was in Norway 3 times, and 3 times I failed because the road was blocked. The other alternative is to go around the fjord, and that's a 4.5-hour trip. Now it's only 15-20 minutes trip because of the tunnel. So one of the challenges here is people can get bored driving to the tunnel. You know, there's nothing to see. It's pretty depressing inside. So what they do is that in the middle of the tunnel, they provided a picnic area. Wow. This is a picnic area, and it does an adit that allows light to get in. So you can see the light. Okay, so you can rest here. And the most interesting part is that to make people entertain, the passengers of vehicles entertain, is they project art images on the wall of the tunnel, so to make the tunnel less boring and less tedious. So one of the worries, as I said again, is that drivers will fall asleep because of the tedium of the long time it takes to go inside the tunnel with very little visual stimulus. So they added these projections of art on the tunnel.
This was a drill and blast tunnel?
It was a drill and blast, yes. No, Norway likes drill and blast. The conditions in Norway are mostly susceptible to drill and blast. I would say that, I don't know, maybe 95% of tunnels in Norway are constructed with drill and blast. Okay, so the world's deepest undersea tunnel was the Eiksund tunnel in Norway. It's on a fjord to connect this island to the mainland. It's 290 meters below sea level. Okay, it's only 7.7 kilometers long. It used 1,600 meters square of shotcrete to service the surface to cover the tunnel surface. 1,300 tons of explosive and 5 million blast holes were drilled to construct this. But as I said, unfortunately, tunnels we have had tunneling in the US is also old. We have many tunnels in New York City, for example, that connect Manhattan to upstate New York or to New Jersey. Also, Massachusetts, Boston had the tunnel built in 1961. Some of them are very old. So Boston's Calhoun tunnel was built in 1961. One of the oldest tunnels is the Hudson River Tunnel. It goes under the Hudson River towards Manhattan. It's already 104 years old. There are tunnels in Baltimore, in the Potomac, in Washington, D.C., where the curves are so tight. They're very tight. Okay, they're very, very sharp curve. And the clearances are very, very low. So what happens is that when the trains come to these portions, they have to slow down to 30 miles per hour. So it is estimated that if you shut down the train services in the northeast corridor of the US, that will cost up to $1 million a day due to congestion, productivity, and other losses. Even those that are quite new are rapidly deteriorating. This tunnel in the Appalachian Mountain was constructed in 1990, but already having serious problem. And the repair will cost $1.5 million per day due to traffic delays when it gets close due to repair. These are the biggest tunnel projects that have encountered big problems in all over the world. We have, unfortunately, the tunneling industry has a pretty dismal record of failures. The biggest of this is the Big Dig Tunnel in Boston, Central Antony Tunnel. It started with 2 billion. The budget was 2 billion. But the final cost is 24 billion. Some say it's even 36 billion. And the delay, it caused a delay of 11 years. So you see, this is 12 times the original cost, and the delays are significant. The other one is the Heathrow Airport Tunnel collapse in 1934, Shanghai Metro in 2003, Singapore in 2004, and Sao Paulo in 2007. But tunnels have very, as I said, very positive contribution to our surface environment. This is how Boston looked like before Big Dig, before the tunnel was constructed. And the delays, traffic delays, especially if you're going to the airport, to Logan International Airport from the downtown Boston, is horrendous. It can take you hours to get to the airport if you are traveling during rush hours. And you see the urban sprawl, we call it the urban sprawl, and it's just horrible. But now this is how Boston looks like, because the tunnel has been driven down. You now have these green spaces, less urban sprawl than before. However, as I said, this is a project that has completely gone in a horrible way. Okay, so budget increased by 12 times the original. Moreover, there's been accident. This is the case where the tunnel wall collapsed on a commuter. So it was a big scandal. so to speak. This is the one in London, the Heathrow Airport tunnel closure collapse. This has been classified as the worst civil engineering disaster in the UK in the last century. Took 2 years to recover, and 250 million costs incurred, nearly 3 times the cost of the original contract. This has been blamed to a catalog of design and management error, poor workmanship, and quality control. It resulted for the tunnel collapse. This is in Sao Paulo, where 7 people were killed. 7 workers with 7. So this is a shaft that will lead to the vertical shaft that will lead to the tunnel. It collapsed. It is very funny, but that in this accident, they were already seeing signs of potential problem. And then instead of doing something, the workers started to take selfies to show what is happening on the ground among themselves. So again, another major failure. Okay, so what is the vision for our center? We develop technologies, and what we want to address is to improve the durability and the life of existing and new underground transportation infrastructures. We have to train next generation of engineers, and we have to do technology transfer. What makes underground transportation a challenge? Well, underground is very complex, very difficult to characterize or anticipate the geology. Material behavior soil and rock behavior is very complex, and there's always complicated interactions between ground and structure. Because of the unexpected ground conditions, there's always project delays and escalation. Tunneling is still very empirical. A lot of methods are still empirical. We use rock mass classifications like Q, RMR. Those are very empirical. What happens is that owners and owners, designers, and contractors often take large risks or are excessively conservative, okay, due to the insufficient information. And usually the design is fixed from the beginning using the limited information, and very little provisions are made to allow for the changes in the design and the construction. So even when the project is going completely disastrous, it continues to burn a lot of money. So this is what we have to do. And our solution is to use a so-called real-time adaptive system. Okay, the real-time, I'll show you. Wait a second. This is the main idea of our center.
Yeah.
Our center focuses on 3 major areas: asset and performance management, condition monitoring and remote sensing, and use of new materials. These 3 areas are prescribed by the Department of Transportation. It's 3 among maybe 12 research areas. So we pick up these 3. And we link these 3 problem areas using an intelligent and data-driven system for underground transportation infrastructures. So this is what we do. So we develop adaptive, intelligent, and data-driven system. Okay, so this is the main core, what we call Amadeus, adaptive real-time geologic mapping, analysis, and design of underground transportation infrastructure. What it is
Amadeus, Professor?
Amadeus,
is one leg of the focus of your center.
This is the core. This is the core concept and technology.
Oh,
everything
that's the
that
core
we do.
Concept. Amadeus is the core concept.
And
Yeah,
may
so
I ask you
everything
one
that we
question, Felipe? Are you aware of if the metro in Santiago or other tunneling projects have faced like a similar problem that what Professor Marte, Chogas?
I'm not.
Are you
I'm
aware
not
of that? I'm not,
sure.
I haven't heard of these
I'm not
issues
sure.
in
I'm
the
not
news, at
sure to
least.
that extent. I'm not sure to that extent. To the extent of the problems that he showed in the beginning, but in every type of underground construction, there are always issues as you move forward in the construction, because when you have tunnels, right, you do a characterization, but it's still a discrete characterization. So you can right, you can do, let's say, field testing, and you can do laboratory testing, but it's always at discrete points. The idea is
Yes,
that
yes.
those points that you address are not as separated, right? You are looking
Yeah,
for
yeah.
them to have some sort of, I don't know, every, let's say a number, every 250 meters, every 500 meters, depending on the extent of the tunnel. Maybe Professor Marte can tell us some details regarding the characterization of the ground characterization of these long tunnels, for instance, for a 60 kilometers tunnels. Every how many meters they do a characterization point.
Okay, yeah. The biggest challenge with underground transportation, going back, going back to Chile, I think because Chile has a strong history in mining, I think
Right.
that has helped you build your underground transportation system, particularly the metro. That has helped a lot. You know, you have that long history and tradition, so that is a very strong basis to start on this type of projects. Um, with regards to ground condition, really the biggest challenge with tunnels is that we don't know what is down there before we start.
Yeah.
Okay, we take a few boreholes, we drill a few boreholes, drill a few samples, and these are at the discrete points, and we try to guess what is in between these boreholes. You know, this sampling. Sometimes we do seismic surveys to characterize the ground, but seismic surveys have also limited resolution and also give us only elastic properties, which is not what we need. We need, properties that include the strength. So these are problems. But the interesting thing with the tunneling is that the more you drill, the more you know about the ground. Okay, the more you drill, the more you know about the ground. Unfortunately, still in our today's technology, we do not use that information.
Yeah.
We do not update. We do not update our design. We do not update our contract. There's always a competing requirement. The owner wants to save money, so they want to spend as little money as possible in the ground investigation, and want to give all the responsibility to the designer and the contractor. The contractor wants to maximize his profit, and so also he wants to do things in the cheapest way possible without incurring problem. At the same time, too, in most tunneling projects, if there is unexpected ground condition, which is always the main cause of tunneling, the contractor can claim more money. Little incentive for the contractor to optimize the design. Can claim more money. So this is the current state in the tunneling industry. So we understand more about ground conditions and how the ground responds as we continue excavation. However, we rarely exploit this in the design of construction because it costs you need money and time to gather the information, and this is what everybody's trying to save. It's difficult to interpret the field data, modify the design, particularly real time, and the lack of flexibility in the contracting system to accommodate changes in design and construction. These are the barriers. So our components of Amadeus are in information technology. We use digital imaging and interpretation, remote measurements, tunnel response, ground computer the tomography, computational tools, and virtual environment. These are the technology that we use. For example, we use different sensors like sensors, instrumentations, sensor networks, LiDAR, digital photogrammetry to assess the tunnel ahead. For example, we have camera placed in front of the tunnel. And as the tunnel is excavated, we take images, and from the images, we turn them into geologic model, like this one. So this is evolving, and the geologic model is being advanced. So we have the imaging, the geology from the imaging, but also from the boreholes, as you can see here. So encounter difficult conditions, then we can try to adapt and modify as we move into the construction. This is the whole step. We have imaging, geological modeling, rock mass classification, tunnel design, computing of tunnel response, and to check if the tunnel is satisfactory. And our hope is to drive the whole system using virtual environments or virtual reality. Okay, so these are some of the models that we deal with. So this is imaging. Oh, no problem. Imaging. This is our virtual reality system. This is our deformation monitoring in the tunnel. There's a modeling that we do. This is parameter identification, computer tomography to detect changes. So we use different types of seismic sensors to detect high stress areas, for example, and potential areas of distress. We have a database.
Section, Professor, that section that you were showing there, what is the extent that you have been able to measure, or you do it in this stage in the lab?
No, you mean this one? Is this curve?
Yeah.
Well, we have our own research mine. We have we have our own tunnel.
You have your own tunnel.
Yeah, we have your own tunnel.
Wow.
So
okay.
We could
okay.
So
okay.
yeah,
you have pictures of your tunnel?
It's called the Edgar Mines. I don't have it now.
Okay. Okay.
Edgar Mines is about 30 minutes drive from campus, but we probably may be the only university in the world with our own tunnel. So
there is one here in Chile.
Oh, is that right? Okay.
Yes.
Yeah. So
there is one here in Chile. I can tell you later. I can tell you later about it. But I knew some time ago that there was a university here in Chile that they have a land and that they did their own tunnel too. And I was very surprised. It's a tremendous effort.
Yeah. That is true. Yeah. So it's nice to have the facility because we could do all kinds of things, develop new sensors.
Absolutely.
Particularly for monitoring excavations, tunnel excavations. So we also, in addition, we want to develop new materials. We want to develop a new set of materials that are sustainable. For example, one of the biggest emitters of carbon dioxide is the cement industry. It's probably second or third producer of CO2, emitter of CO2. It releases a lot of CO2. So we want to change how cement is produced by using natural cement, by using additives to prevent the release of CO2, and also using additives to capture CO2. We hope to develop also completely automated tunnel construction. This is the ultimate goal. using machine learning and AI. Gave a lecture to your students on machine learning and
Yes.
encourage them to learn machine learning because it's a growing industry. So, but we are more and more we're using machine learning to understand what goes in the underground. We are supposed to develop or train workforce who will be working with tunneling industry. We have courses related to transportation infrastructure. We have a degree. We have a master's and PhD degrees in underground construction and tunneling. And we're the only one in the US to have a degree on underground construction and tunneling. And it's a multidisciplinary program run by civil engineering, mining engineering, and geology and geological engineering. So 3 departments run the program. We have also minor areas or major areas for students. We have short courses, seminars. We have a K-12 program. Every summer, one of my faculty recruits children from nearby schools, give them idea of tunneling. They have excursions, field excursions to see how tunnels are operated from the tunnel control room. So we cover all aspects. More and more, we're being asked to have this K-12 and underground participation. We're supposed to transfer technology. So to the industry, we have continuing education courses. Some of the courses are in person, some of the courses are online. We have an online professional degree program. People can attend, don't have to be in the campus, and they get a certificate. They need it for getting work, for example, or advancing to their careers. We disseminate the results all over. We have 2 web pages. We go to conferences, we meet with contractors, and all of our reports are available in different databases in the US. This is what I use to entice, to convince the students to pursue career in underground transportation infrastructure. Okay, I tell them this is a very bright future for you if you want to have a stable and high-paying career. All our students, even before they graduate, they are already recruited by construction companies. All of them are employed immediately. Some of them are in a hurry to leave the university because they are expecting good pay. Many of our students are engaged in traineeships. They do some of the research together with the company. So they have industry traineeships where they learn about tunnel constructions, and most of them work in the field. So yeah, I do believe that careers in the underground transportation infrastructure industry will be a very lucrative opportunity in the future. There will be high demand for growth. As I said, we will be building more and more tunnels. In California now, 1 in 6 of construction workers work in the underground. They call it the underground economy. Underground constructions last for many decades, for years, even decades. So it's very rare to have a long project like that. In many civil engineering projects, you're lucky to have a project that lasts maybe 3 years, 4 years. But because Miras can last even decades. There's a lot of education. There's a huge opportunity all over the world because a lot of these tunneling companies are multinational. They operate all over the world and like to send workers to the different projects all over the world. There's so much diversity now that is required. Also, the work is very diverse. You can work from office to the field. There's a lot of growth. One of my former PhD students now is a vice president of one of the biggest construction companies in the world. He's a vice president now. He was my PhD student maybe 12 years ago only, very young, but already BP. Okay, and of course, it's the pride to work in landmark projects that have major impact to society. So this is what I use to recruit students.
Yeah. Oh, but very, I mean, very interesting, and I mean, and the work in the center that you're working on is, I mean, very interesting. Yeah. So I wonder, I mean, if we can discuss later with Felipe to see, yeah, maybe there are some opportunities here to do something similar. But so I'm very, and I'm very glad that you came here, and I hope you have a good time, and yeah, and maybe can build ties with Felipe and other students later. So I'm very happy. I mean, as a head of the department and also as a transportation engineer. I'm working in transportation, but more in the demand area. So I'm very happy that you came here, and we have the opportunity to work with you. Yeah. So
yeah, well, likewise, I'm very thankful for University of Chile, your department, having me here. I've truly enjoyed my stay. I wish but it was longer, but there's been a visa problem. Getting a long-term visa in the US, in Chile, has become difficult because they changed the visa issuance. It used to be the Ministry of Foreign Affairs issued the visa, but because of mass illegal migration to Chile from the neighboring countries, it's now the Ministry of Internal Security, something like that, is the one issuing the visa. And because of that, it was so difficult to get a long-term visa. So I decided to come as a tourist. So, and tourist visa is only for 3 months. So, but I really enjoyed my stay, and I'm very, very grateful for the opportunity to be here. I'm very thankful for all the help from Felipe. So he'll help me a lot, and I really hope that we can develop something more long term.
It would be really,
particularly in this
really good to. It would be really good to develop something around what you showed us here. It's I think it was fascinating. It was a fascinating presentation. I have a question. When in your team, it's your team of researchers is for sure a multidisciplinary team with a core probably of geomechanics and geotechnical engineers, but here you have many inputs from the structural colleagues, from the transportation colleagues, from industrial colleagues.
Yes, this is truly a multidisciplinary area. We have faculty from civil engineering, mining engineering, geological engineering. We have structural engineers. We have traffic engineers. We have computer science people working with us with the latest advances in machine learning. So they're helping us develop machine learning tools. Yeah. So yeah, so it is multidisciplinary, and not only at Colorado School of Mines, but also in the California State University in Los Angeles and Lehigh universities, who are our partners. So one time we had, I think, 15 faculty who are affiliated with the center. So it's a big
it's a big number.
Big number.
Yeah. So keeps a lot of people busy. So.
Yeah.
Okay, so Professor Martin, so I have to run now for a meeting. So I'm very glad that you have the time to make the presentation, and yeah, and very glad that you came here, and wish you like a good trip back home.
Thank you very much. Thank you.
All right.
Thank you.
Thank you, Professor Guevara. Thank you, Professor Marte, again. Okay, so I will stop the recording.